All right, so now we've set everything up for our titration. We're going to see what a titration is. So the first thing I'm going to do is I'm going to notice the volume that this says my solution is at. So this is my standard solution of sodium carbonate. And I'm going to record that. I'm going to get myself eye level as best I can, being short. And it's on 0.0. Now yours might not be, it might be down here at 1.3 or whatever. And I'm going to write that down on a bit of paper. So somehow I got my initial to be 0.0. That's complete luck. And I'm going to make sure I've got 3 aliquots ready to go. Here's one I prepared earlier because I know how long it takes to pour out. I have rinsed this with the solution I'm going to transfer already. And I've already done stuff in pipetting, so I'm not going to take a lot of time with this. We're explaining it. But basically I'm going to fill it past the line, quite a lot past the line, so I don't have to rush. The idea of setting up 3 is so that we can compare our colours to actually see that we're being consistent with our colour for our indicator change. Right, and what I'm going to do is just roll my thumb a little bit, get my eye level to the line, and hopefully the level of solution will drop slowly. Now, if you find this really hard, use the pipette filler to do it for you instead, because it has a little trigger to release everything out of. Okay, so you can use the wheel if you really have to, if you find what I'm doing too hard, and then when you've got it on the line, go over your flask and release it. But I'm using my thumb because I'm old school and I find it more reliable. As long as I've had enough coffee today. Otherwise I'm shaky, and I'll use that. So as I say, I know this takes a while to pour out. Don't force it out, please. Because then you might get that last little drop out. That last little drop needs to be there for it to be 20 mils. Okay, it's calibrated to that. Here we go. Now, I don't trust, even well caffeinated, I don't trust that I'm 100% accurate in getting all of that to pour right down the bottom. I don't know if some of those drops on the side are water or hydrochloric acid. And I know darn well when I touch that to the side, which is our last bit, and there is a wee drop left, that's meant to be there. I don't know if those drops are hydrochloric acid or water from when I rinsed it. So, because it's not the concentration that matters now, but the amount of hydrochloric acid, I'm going to rinse the walls down with distilled water, just to make sure every drop of hydrochloric acid is in there. Then I'm going to use my indicator, and for this one it's methyl orange, and I'm going to use up to 5 drops. And we'll see that it starts orange, but as soon as it touches the acid, it goes a reddy colour. And if it was a base, it would go yellow. I want to go back to orange, and pink or red to orange is quite hard to see, so I might end up going to that first drop of yellow that stays, but we have to sort of make a judgment call. This is a hard experiment, which is why it's not your assessed one. It's a hard one to pick the end point or colour change for. I wouldn't use this one in an assessment because the colour change is too hard. Okay, we're going to use a much more obvious colour change. I'm not going to set up the third one simply for time, and I want to get into how you do the actual titration. So I've recorded my initial volume, I've made sure my funnel is off there, and what I'm going to do, I'm right-handed, so I'm going to be swirling this with my right hand so it's got more control. And I'm going to be turning this tap with my left hand while I do it. Now, if I notice anything coming out of here hits the side, I have to stop and wash the walls down again. I've got to make sure everything goes in the bottom. So, here we go. And the first one I'm going to do, I think I said to you before, the first one we always disregard. That's because it's doing 2 things. It's what we call our rough titration, and it's finishing the rinsing process. Okay? So, I'm actually going to intentionally go too far. I'm just going to pour it until I see it change colour. Okay, can we see some yellow starting to come through? But it's still just a diluted version of that colour, isn't it? It hasn't actually changed yet. So that's why we have the other one to compare it to. Oh, has it changed, or am I imagining things? Right, I'd call that yellow. I'd say it's changed. Now, I've definitely gone too far. That's okay. That's okay. So in here, I've gone to exactly 10 mils. Okay, that's interesting. This is going to be a really... which is only just 3 significant figures actually. So my rough titration, I might get the camera person just to scan down. I'm going to write rough underneath it so I know not to use this value for my calculations. So my rough value is 10 mils, okay, or 0.0100 litres when I do my calculations. That'll be another video. So because I know that's 10, that becomes my value for my second titration. I know I overshot, so this is the bit that's really good, really important for the your techniques. I'm going to drop it down to about 8 mils, so 18 in this case because we've started at 10. I'm going to drop it down to 18 without doing anything. I'm actually literally just going to put it there and let it pour till I see this hit 18, and then I'm going to stop it. So I'm trusting my technique here. I can see some yellow starting to form, so I give it a swirl. It's still pink, and if I'd done a third one, I could check that and see that it's still pink. But now I'm going to go really slowly. And this is where you'll work out whether you should be swirling with your right hand or your left hand. I can see some droplets up there. I'm going to be really pedantic and make sure that those droplets are definitely not that they're just water, so wash them down. Now I go really slowly. If you partially turn the tap, lift your flask, and I'm sorry if that's shielding the camera a bit, but partially turn it, you'll see that you should see it drips rather than flowing. And as I do it, I swirl. And I'm not trying to go as far as that yellow. The yellow's starting to form, so I'm going to now go incredibly slowly. Basically, 1 drop swirl, 1 drop swirl. This bit takes a lot of time, but we're after precision. That's why I do it down to 18 mils. Imagine, so I already used most of the volume up, because imagine doing that from the 10 mil line. Drop swirl, it would take forever. So we're comfortable that it's going to be near 10, so let's do 80% of that. If it was 20 mils, you'd probably do 18 mils actually. You could do quite a lot, and then go slowly. And as soon as you see that colour change starting to come through, you've got to go really, really slowly. And if you accidentally do 2 drops, don't worry. 2 drops is about 0.1 mils, so you're going to be out by nothing. I've got it dripping in case you wonder what I'm doing there. It's still technically pink, but I can see it holding its yellow colour. Right, might stop there. I would argue that that is peach. That's orangey, peachy colour. Would you say that? And it's not pink anymore. So I'm going to stop there. This one I'm not going to tip out at all. I'm going to keep it there because that's the colour I'm aiming for, not this one. This is the colour I'm aiming for every other experiment. When I get that colour, I stop. That's too far. And of course the pink that we had is not there yet. I read this off and it says 19.8. So that shows how close 10 mils was, because 9.8 is orange and 10 mils is yellow. So that's the difference 0.2 mils can make in a titration. From being, what I'd suggest is probably about right, to being overshooting and wrong. Your aim is to get 3 values after the rough one that are plus or minus 0.1 mils. So that means, say 9.8, 9.7, 9.9 would be absolutely fine. And then you'll take the mean or average of those tighter values, and that will give you your volume that then you can work out your amount from, because your amount from, and from there we can find the amount of hydrochloric acid, and therefore know its exact concentration. But again, that will be either tomorrow or next week where we look at the calculations of this.